In the last class, we saw that the idea of causality was further developed by James Stuart Mill, who proposed a few very concrete methods of ascertaining the causal factors behind a phenomenon, and these are also called the canons of induction. So, we are now talking about James Stuart Mill's ideas of causality. Yesterday, we had studied this method of agreement. So, today let us see it in formal statement. If two or more instances of the phenomenon under investigation have only one circumstance in common, the circumstance in which alone all the instances agree is the cause, or it can also be the effect of the given phenomenon. So, as I said that if a event happens in two circumstances, and if you analyze the antecedent situation, the situation prevailing just because of occurrence of this, just before occurrence of this, the phenomenon, and you notice that in all the situations where the phenomenon occurs, the antecedent factors are all different except one. Only one circumstance is common, then the circumstances in which they agree is the cause. We have also studied the method of difference. So, let us look at its formal statement. The method of difference says that if an instance in which the phenomenon under investigation occurs and an instance in which it does not occur have every circumstances save one except one in common, that one occurring only in the former, that means where the phenomenon occurs. The circumstance in which alone the two instances differ is the effect or the cause of an indispensable or an indispensable part of the cause of the phenomenon. So, here Mill says a phenomenon occurs, an event occurs in two situations, and the situation prevailing before the occurrence of that event, they are all the same except one particular factor. That factor is present in the situation where the event happened and absent in the situation where it did not happen. Then he says that that factor can be said to be a causative factor. Notice the way he frames the statement. He says that the factor that we have identified that was present in one situation, absent in the other situation, the difference is the cause. It can be the indispensable part of the cause, a factor in the cause, and it can also be the effect. Now, the third one, according to John Stuart Mill, is a joint method using both agreement and difference. He says that suppose two or more instances in which the phenomenon occurs have only one circumstance is common, and in comparison, two or more instances in which it does not occur have nothing in common except the absence of that circumstance. In that case, the only circumstance in which the two sets of instances differ is the effect or cause or a necessary part of the cause of the phenomenon. Now, let us understand. In case of the method of agreement, we have collected instances where an event happens. In case of the method of difference, we have collected a set of instances where in some cases it happens, in some cases it does not happen. Now, in the joint method of agreement and difference, we talk about a situation where we have collected a set of events in which that particular phenomenon happens, a set of events where the particular phenomenon does not happen, and we are studying the antecedent situations. Now, where the situation where it is common, that means it happens, then two or more instances in which the phenomenon occurs have only one circumstance is common. That means, where it happens, then we are looking for an agreement, the particular factor that is common to all the situations. And we are also looking at, in this case we are also looking at two or more instances in which it does not occur, and then we are looking at what are the differences. So, we are looking at agreement as well as differences, and then we are pointing. So, in this method, in the joint method of agreement and difference, we take into account both situations where the event happens, a number of situations where the event happens, and look at the agreement, a set of situations in which it happens and another set in which it does not happen, we look at the difference. When all these are put together, then we can infer what is the cause, and that is the joint method of agreement and difference. Now, let us look at the fourth method that Mill talks about. It is the method of concomitant variation. He says that consider two phenomena A and B, and suppose you find that whenever A varies, B varies in a particular manner. That means, if A goes up, B always goes up, or if A goes up, B always goes down. Then A is either a cause or an effect of B, or is connected with it through some effect of causation. So, here you have a situation where all the time you are considering the causal connection between two things A and B. If whenever A goes up, B always goes up, or whenever A goes up, B always goes down, then you can say that such a connection exists. The fifth one is the method of residues. In this method, Mill says, suppose an event happens, and in the situation prevailing before that, there are a few different factors, and the method is to subduct from any phenomena such part as is known by previous induction to be the effect of specific antecedents, and the residue of the phenomena is the effect of the remaining antecedents. Let us illustrate. Suppose the phenomenon B has happened, and when you explore the situation prevailing before the event B occurs, you find that there are a few factors, say P, Q, R, S, T, whatever. And from earlier knowledge, you know that B cannot be caused by P, B cannot be caused by Q, B cannot be caused by R, and so on and so forth, but you do not know what is the effect of T is. You know that everything else cannot have caused B. Then you might conclude that the remaining residual factor that is present in the prevailing situation T is the cause of B. So, it is residue. In what sense residue? Because all the other elements prevailing in the antecedent situation could not have caused. From our earlier knowledge, we know that these could not have caused the event B. So, you have to subduct from any phenomenon, the phenomena is B, you have to subduct such part as is known by previous induction to be the effect of specific antecedents. That means, from B you have to subduct whatever is the result of P, whatever is the result of Q, whatever is the result of R, whatever result is F, S, you subduct that. Therefore, you arrive at what is remaining in B, and you do not know what caused B, but you know that P cannot cause that, Q cannot cause that, R cannot cause that, S cannot cause that, U cannot cause that, but you do not know the effect of T, and so you conclude that T is the causative factor behind B. So, these 5 are the recommendations of John Stuart Mill to look for the cause of any situation, any phenomenon, any event. Let us illustrate these canons of induction, as it is called, by using certain discoveries in scientific history. The first is, for example, Ohm, Georg Ohm. He established a connection between the voltage and the current of any suppose there is a resistance and you connect a source and a current flows. So, there is a V and there is a current here I. And he established that these two follow a relationship. If you plot V here and I here, then they follow a specific relationship like this. That means, whenever V increases, I increases, and it is also true that whenever I increases, V increases. So, therefore, he would say that you can either say V is the cause of I, voltage is the cause of the current, or if you allow a current to pass through a resistance, a voltage appears across it. So, that will be the current is the cause and the voltage is the effect, both is possible. The next example I will cite is in the late 1890s, the X-ray was discovered by Roentgen. And when X-ray was discovered and the news reached France, then Becquerel guessed that the X-ray, the emission of X-ray is a property of what is known as phosphorescence. Phosphorescence. What is phosphorescence? Certain substances absorb sunlight, absorb the energy in sunlight and then re-emit it during the dark. So, this is called the phenomenon of phosphorescence, and it was known that one particular compound called potassium uranyl sulfate is phosphorescent. And so, he wanted to test whether it emits X-ray or not, and then the method he employed was to take a crystal of potassium uranyl sulfate and then use a photographic plate. If the photographic plate becomes exposed, that means upon development it turns dark black, then it is exposed, which means that it had emitted X-rays. So, this is the way he tried to test. Now, in fact, he exposed potassium uranyl sulfate in sunlight, and then the next day he exposed the photographic plate, it turned black. So, he was convinced that it is emitting X-rays and it is a phosphorescent material. But for the next few days there was cloud in the sky. So, he put the whole contraption in his drawer, and after the again sun came back, he took it out and wanted to resume the testing. While he wanted to do so, before he started, what he did was to develop one photographic plate to check that it is all right, and to his surprise he found that it has turned black, which means that even though the potassium uranyl sulfate did not absorb sunlight, it was not exposed to sunlight, it was in the drawer, still it has emitted X-rays. This was a serendipitous discovery, but the importance of serendipitous events can be absorbed only by a trained mind, and Becquerel's mind was trained. So, he for a few months he continued testing this particular phenomenon from various angles. Now, what did he actually do? He was having the hypothesis that potassium uranyl sulfate is emitting the X-rays. In order to test it, he exposed potassium uranyl sulfate to sunlight for a few days and tested, it turned black. He did not, he kept it in the dark for quite some time, and then again brought a photographic plate in close vicinity. Again upon development it turned black, which means that there was no difference in the blackness, which means that it is not due to phosphorescence, it is actually emitting the radiation all by itself. Which method did he apply? Notice that he created deliberately situations in which the antecedent situations are different. Sometimes you are exposing to sunlight, sometimes you are not exposing to sunlight. But in all the circumstances, the result was the same, it turned black. And what was common between them? The only thing that was common between them was the existence of potassium uranyl sulfate. So, he concluded that potassium uranyl sulfate emits radiation on its own using the method of agreement. Now, at that time, Marie Curie, who later became known as Madame Curie, she was completing her masters and was looking for a problem to work on for her PhD. And she chanced upon this particular discovery of Becquerel. She decided to ask the question, what causes this radiation? In fact, she named it as radioactivity. So, her question was, what causes, here we are talking about the cause. Now, notice that when she started the work, it was known that potassium uranyl sulfate emits radiation. So, the natural question is it the property of the whole compound, or is it the property of the elements in it? In order to test, she created a few compounds of potassium, a few compounds of uranium, and a few compounds of sulfate compounds. And she found that the radiation or radioactivity is not there unless the compound contains uranium in it. So, again she was employing the method of agreement, because in those situations where radiation was observed, radioactivity was observed, the only circumstance in common was the existence of uranium. She was also employing the method of difference, because there was situations where the potassium compounds, other compounds other than uranium compounds, potassium compounds were not emitting radiation, sulfate compounds were not emitting radiation, but the uranium compounds were emitting. What is the difference? The difference was in the existence or non-existence of uranium. So, she was actually applying both the method of agreement as well as the method of difference. Well, she then homed on the fact that uranium is radioactive. She then asked, is uranium the only element that is radioactive? In order to test that, she gathered a few different minerals and then tried to test the radioactivity, and she found that she analyzed, chemically analyzed and isolated the different compounds in that mineral, and each one she tested for radioactivity. So, she got a few minerals that are radioactive, she isolated the individual compounds in it, and then she tested each compound and found that the compounds are not radioactive unless they contain either of two different elements, uranium or thorium. So, again she was applying the method of difference, because the difference between something being radioactive or not radioactive was in the existence or non-existence of uranium and thorium. So, here she was using the method of difference. And in the circumstances, in the situations where multiple compounds were emitting radiation, the commonness, the things in which they agreed was the existence of either uranium or thorium. What should they do next? She again asked, so uranium or thorium, so uranium and thorium are radioactive, thorium is also radioactive. Is there any other radioactive material? Now, what would be her method? What she did was, she argued that if I obtain certain minerals, naturally occurring minerals that contain uranium and thorium, then the radioactivity of that mineral per unit weight mass of the mineral would be the sum total of the radioactivity emitted by the uranium content in it and the thorium content in it. So, she knew how much the unit amount of uranium can emit, how much radiation a unit amount of thorium can emit. So, she could account for the amount that these two elements would emit. If any mineral contains more, then the residual radioactivity will be because of some residual substance. She was actually applying the method of residues. She found that in most minerals occurring in nature, this is satisfied. That means, the amount of radioactivity is a sum total of the amount of radioactivity due to uranium and thorium. But in one mineral called pitch blende, in that mineral she found that the amount of radioactivity emitted by pitch blende is exceeding by far exceeding the amount of radiation that can be accounted for by its uranium and thorium content. So, she chemically analyzed the pitch blende and found how much uranium is contained, how much thorium is contained. Therefore, this much of uranium can emit this much of radiation, this much of thorium can emit this much of radiation, add them. But she found that pitch blende is actually emitting far more radiation. Therefore, the residual amount of radiation must be emitted by some residual substance existing in pitch blende. Law of residues, method of residues. When she found that, her husband Pierre Curie became interested, because he saw that it is likely to lead to something real good. So, he also joined this quest of finding the other radioactive substances. What would they do? They gathered a large amount of pitch blende, in fact, they filled up almost a whole room with truckfuls of pitch blende and then started analyzing that. The huge amount of pitch blende has to be processed, chemically processed. It would be an early morning to late evening affair in chemically processing the huge amount of pitch blende to isolate the different elements in it, different compounds in it. And she found, she isolated the amount of uranium, isolated the amount of thorium. The remaining substance is also radioactive. Then she again chemically separated the different compounds in it. She found that there is bismuth in it and barium in it. The two things, bismuth and barium. And these two compounds of these two substances are emitting radiation. But she knew that bismuth is not radioactive, barium is not radioactive. Still, whatever she could extract from pitch blende containing bismuth was radioactive, the one containing barium is also radioactive. This implies that there are unknown elements that have properties similar to bismuth and another unknown element that has properties similar to chemical properties similar to barium. Why? Because if their chemical properties are the same, then when you are trying to extract barium, that element will also remain in that. So, then she wanted to study these two, and by studying that means by carefully extracting whatever was the substance already extracted that contained that additional substance, but she carefully eliminated barium from it. Whatever remained was first she attacked bismuth compound, and what remained was extremely radioactive, 300 times radioactive, more radioactive than uranium, and then she named it as polonium. She was from Poland, so after her motherland she named it as polonium, and then they targeted the barium compounds. They carefully extracted all the barium from it, whatever remained was also radioactive, and from there they extracted a new element called radium, and they got a Nobel Prize, both got Nobel Prize for this discovery. Notice that whole pursuit was following Mills' recommendation regarding how to find causality, and they were trying to find what causes radioactivity, and they found that very definite elements cause radioactivity. Before we end the topic of causality, let us briefly talk about where we stand today. In fact, after the contribution of Hume, Kant, Mill, many other philosophers tried to contribute to it. They enriched the idea of causality, but more or less we still find out causality using Mill's method, but the ideas that were proposed before have been refined. For example, out of Aristotle's causality, if you recall, Aristotle 4 types of causality were material cause, efficient cause, formal cause and final cause. Out of that, final cause was already jettisoned by Galileo, and after that it was not used, and scientists after that argued that only material cause will stand. The formal cause, the form of the sculpture that is in the sculptor's mind is a part of the sculptor's, therefore, that is a part of the efficient cause. Out of the 3 recommendations by Hume, if you recall, one was law of precedence. He said that the cause must precede the effect. Now, we say no, the effect cannot precede the cause. The second one was the law of contiguity, that has been abandoned because, as I cited the other day, the effect of moon, a distant body, causes the tides which is here. Obviously, these are not contiguous. So, contiguity is abundant. Constant conjunction, whenever the cause happens, the effect should happen, that means always should happen. Now, that has also been abandoned because of the situation that a particular causative agent for a disease, for example, if that is present, that does not cause the disease always in all humans, because humans have there are other factors that can prevent it from occurring. So, in that case we cannot call constant conjunction, always it will happen, that cannot be said, but in those situations we take recourse to the statistical method. So, this has gone into the statistical method. So, even though it does not happen always, if it happens in a statistically significant cases, then we say that it is a cause, and the way of saying statistical significance we will come to later. Mills causality has stood. But with one word of caution, that is, from these one important confusion may remain is that suppose the event A has happened, or event A has happened, and before that the prevailing circumstance were say B, C, D, E. Can you say B is the cause, C is the cause, D is the cause, E is the cause? No. So, there is no plurality of causes. This is wrong. Cause is unique. For any event there is one cause, which means if A has happened and in the antecedent situation you find the factors B, C, D, E, then the cause is the whole situation encompassing, taking into account all of these. This is the cause. Individually these are not the causes. Now, the Mills causality, the methods he proposed to find out the causal factor, these are all these individual factors. These are called the factors, not the cause. For example, if you plant a seed, a plant grows, a sapling grows. Now, that event, if you analyze it, then you might say the existence of the seed is the cause. Another person may say no, because there is a soil there, soil is the cause. Another person might say no, unless there were water it would not sprout, and therefore, there must be water, water is the cause. Another person may say no, there is oxygen in the air and that is also the cause. So, different people from different points of view might identify the cause in a different ways. That is wrong, because the cause is the concurrent occurrence of all these factors. Each one, existence of the cause is a fact, existence of the seed is a factor, existence of water is a factor, existence of oxygen in the air is a factor. All these conditions put together is the cause. So, we do not have the idea of plurality of causes. We now understand that Mills causality, the causes that we can identify using the method of agreement, residues and things like that, these are individual factors. And the cause is the immediate antecedent of an effect. That is how we understand causality. Causality is a very important phenomenon in nature, and it is independent of our consciousness. It is a fact of nature, and science grows by trying to find the causes of everything.